All right, welcome to the deep dive. We're going deep, deep, deep today into AWS, Amazon Web Services.
Yeah, AWS.
hmm
Like everybody's using it, right? But not everybody knows how it really works.
Yeah, it can be pretty intimidating. So many services, so much jargon. So we've gathered some really good introductory material, and we're going to try to break it down for you.
Make it clear.
Yeah, like demystify it. Focus on the core stuff about AWS infrastructure and security.
The fundamentals.
Exactly, the fundamentals. So think of this deep dive as your shortcut to understanding AWS,
Yeah.
What are the essential building blocks?
Yeah, no matter your level.
Right. Whether you're a seasoned techie or just curious about the cloud, we're aiming for clarity and, we want to keep it interesting.
Definitely.
No fire hose of technical terms,
Right.
just practical understanding.
Yeah.
Okay, so we've got a roadmap for today. First, we'll explore the AWS global infrastructure, the physical locations and all that.
The foundation.
Yep, the foundation. Then we'll take a quick detour to the AWS website. It can be a bit of a maze, so we'll highlight some key areas.
Navigation tips.
Exactly. After that, we're tackling IAM.
Identity and access management.
Huge for security. We'll break down the essentials. And finally, we'll dive into VPC, the virtual private cloud.
Networking in the cloud.
Exactly. So let's start with the very beginning, right? The AWS global infrastructure. Where the magic happens, sort of?
Yeah, that's where it all starts. This global network of data centers. It's what makes all those AWS services possible.
Yeah.
And we have to understand regions and AZs.
Regions and AZs. Sounds geographical.
It is. Think of a region as like a specific geographic area, right? You've got US East, Europe West, Asia Pacific.
Okay.
And each region operates independently. It's like its own little AWS world.
Interesting.
And within each region, you've got availability zones or AZs. These are like one or more separate data centers.
Oh, okay.
They're physically separate, far enough apart to minimize, any risk from local outages.
Or a power outage or something.
Exactly. But they're close enough to provide those low latency connections within the region.
I see. So regions are the broad areas, and AZs are the specific data centers within those areas.
Right.
Okay. Now, if I want to host my super cool app on AWS, how do I choose which region to use?
That's a great question.
Yeah.
And there's a few things to consider. First off, data compliance.
Oh, right.
Huge these days. Are there any regulations about where your data has to be stored? Geographically?
Yeah.
So that might limit your choices right away. AWS is really good about providing control for that kind of thing, keeping data within specific boundaries.
Oh, that's good to know. So what else should I be thinking about?
Well, think about your users, right? Where are they located?
Okay.
If you choose a region that's closer to your users, you'll get lower latency.
Meaning faster apps, right?
Exactly. Faster, smoother experience for everyone. Nobody likes a slow app.
True. Now, what about the services themselves? Are all AWS services available in every region?
That's a good point. While AWS tries to keep things consistent globally, there can be variations.
Oh, okay.
Some newer services, some specialized ones, they might not be available everywhere.
I see.
So double check that the specific services your app needs are offered in the region you're looking at.
Makes sense. Don't want any surprises there.
Definitely not.
Now, I vaguely remember something about pricing differences between regions.
Yeah, that's true. Pricing for many services can fluctuate between regions.
Okay.
Local costs, demand, all that can play a role.
Mm-hmm.
So while it might not be the main factor, it's worth comparing.
Yeah, every penny counts. All right, so choosing a region, it's a balancing act, right? Compliance, user location services, and cost. Okay, let's move on to the AWS website itself. I'll be honest, the first time I landed there, I was a bit overwhelmed. So much going on.
Oh, yeah. It's a lot to take in. So much information.
Yeah.
But it is your central hub for everything, AWS. It's os.amazon.com, by the way. You'll find in-depth details about all the services, technical documentation, pricing breakdowns.
Okay.
It's worth spending some time just poking around, using the search bar, exploring different sections.
Yeah, get a feel for it.
Yeah, it's like the grand menu of all things AWS.
Right. The gateway to the AWS universe.
Yeah. All right, let's move on to something super important. IAM, Identity and Access Management.
IAM. It's like the security guard for your AWS environment.
Ooh, I like that analogy.
Make sure only the right people and services get in.
So IAM is all about managing who can access what in my AWS setup.
Precisely. You create and manage identities. These could be users, groups of users, even applications. And you control what they can do.
Good.
AWS relies on IAM for two key things: authentication and authorization.
All right, break those down for me.
Authentication is proving who you are. Like, are you really who you say you are?
Got it.
And authorization is, what are you allowed to do? Once you're in, what access do you have?
So it's like checking your ID at the door and then giving you a specific key card for certain areas. It's exactly.
Okay, what are the most important things to know about IAM?
Well, like many things in AWS, IAM itself is a global service.
Okay.
So you configure it once, and it applies across all your regions.
Oh, that's convenient.
It is. And it allows you to have multiple people accessing your AWS account securely.
Meaning I don't have to share my root password with everyone.
Exactly. Never share your root password.
Got it.
And here's the really powerful part. Granular permissions.
Okay.
You can specify exactly what a user or a service can do, down to the specific action on a specific resource.
So I can be super specific about who can do what.
Yeah. Like this user can read this file but not edit it, that kind of thing.
Oh, that's powerful.
It is, and it's vital for good security.
What else can IAM do for me?
Well, it's essential for securing your applications that run on AWS. You can manage their permissions to access other services. And you absolutely should enable multi-factor authentication, or MFA.
MFA, yeah, I've heard that's important.
It is. Adds an extra layer of security. And IAM also supports identity federation.
Okay.
That means you can connect your existing corporate identity systems, like Active Directory, with AWS.
So my users can use their regular logins.
Exactly.
Seamless.
Convenient. Any other key points about IAM?
Absolutely. IAM keeps detailed logs of all the identity-related activity. That's crucial for audits and compliance. And it also follows PCI DSS,
Which is?
Payment Card Industry Data Security Standard.
Right.
If you handle credit card info, you need to be PCI DSS compliant.
Okay, good to know.
And IAM integrates with tons of other AWS services. It's really the control center for access.
Right.
One small technical thing. IAM works with eventual consistency.
Okay, what does that mean?
So if you make a change, like to a user's permissions, it usually happens really fast.
Right.
But there might be a tiny delay, a few seconds at most, before that change is reflected everywhere in AWS.
I see. So it's not instantaneous, but pretty close.
Exactly. And the best part, IAM is free to use.
Oh, bonus.
Right. Free security. I like it.
And if you need temporary access to resources, there's the AWS Security Token Service, or STS.
Right.
It works with IAM to issue temporary credentials.
Got it. So IAM, free, global, granular, and essential for security. Pretty impressive.
It is a pretty powerful service.
Now, you mentioned IAM identities, users, user groups, and roles. Can you unpack those a bit more?
Sure. These identities represent who or what needs to interact with your AWS resources.
Yeah.
Users are like individual people or applications. They need permanent access.
Okay.
Each user gets their own unique security credentials.
Right, like a username and password.
Exactly. And something called access keys.
Access keys.
Yeah, it's an access key ID and a secret access key.
Okay.
You use them to interact with AWS programmatically.
Oh, I see.
Through the AWS command line interface or CLI,
Right.
or using SDKs.
Right.
And here's a crucial best practice. Enable MFA for all your IAM users, especially the ones with admin privileges.
Makes sense. Double the security. So we've got individual logins for people and applications. What about user groups?
Groups are a way to organize users, right? You put multiple users into a group,
Okay.
and that you assign permissions to the group, not to each individual user.
Oh, I see. So it's like giving everyone in the group the same key card.
Exactly.
Yeah.
Makes managing permissions much easier, especially for teams. It's a best practice to use groups.
Right. Keep things organized. Now, roles sound a bit different.
They are. Roles are for granting permissions to AWS services or for temporary access
Okay.
without having to share long-term credentials. Like, imagine you have an Amazon EC2 instance, which is like a virtual server in AWS.
Right.
You can assign an IAM role to that instance, allowing applications running on it to access other services securely.
Oh, that makes sense. So the instance itself has permission.
Exactly.
Yeah.
And you don't need to put permanent access keys in your application code.
Much safer.
Right. Roles are also used for delegation. Like, say a user in one AWS account needs to access resources in another account.
Lovely.
They can temporarily assume a role. No need to share long-term credentials.
That's clever.
It's a really good security practice.
Okay, we've touched on best practices a few times. Let's really dive into those IAM best practices, the essential do's and don'ts.
Absolutely. Security in the cloud is all about good practices. And the most important one, secure your AWS account root user credentials.
Right.
This is the email and password you use when you first created your account. Treat them like gold.
Okay.
Store them securely. Only use them for those really high-level account management tasks, like changing your account settings.
Got it.
And if you can, lock away or delete the root user's access keys,
Why is the root user so special?
because it has complete access to everything in your account,
Oh, wow.
like literally everything.
Yeah.
So if those credentials get compromised, it's a big problem.
Makes sense. Like the master key.
Exactly. Keep it safe.
Okay. Root user locked away. What's next?
Create individual IAM users for everyone who needs access. Never share the root credentials.
Got it.
And use groups to manage those users like we talked about.
Right.
Another big principle is least privilege. Only give users the permissions they absolutely need.
Oh,
Don't over-permission.
Makes sense.
If someone only needs to edit one file, don't give them access to the entire folder.
Right. Minimize the potential of damage.
Exactly. And whenever possible, use AWS managed policies.
What are those?
They're predefined sets of permissions that AWS has already created for common scenarios.
Oh, okay.
They're a good starting point, and AWS keeps them updated.
Convenient.
Yeah. And you should configure a strong password policy for your IAM users.
Okay.
The default requires at least 8 characters, a mix of uppercase, lowercase numbers, and symbols.
Right.
But you can customize it to be even stricter.
Oh, I can crank up the security.
You can. And if you change the policy, the new rules apply when users change their passwords.
Okay.
Just a heads up. IAM doesn't have a built-in lockout policy.
Whoa.
It won't automatically disable an account after too many failed logins.
Oh, I see.
And the password policy doesn't apply to the root user or access keys.
Got it.
So if you want to be really sure, you might need to manually reset passwords and force everyone to update.
Good to know. What other best practices should we be aware of?
Well, we've already talked about MFA. Absolutely crucial.
Right.
And practice regular credential rotation. That means changing passwords and access keys regularly.
Okay.
And get rid of any credentials that aren't needed anymore. If someone leaves or a service is shut down, revoke those permissions.
Clean up. Good hygiene.
Exactly. You can also use policy conditions for extra security, like restricting access based on IP address or time of day.
Oh, that's cool.
Yeah, it's powerful. And monitor your account activity. Look for anything suspicious.
Right. Stay vigilant.
And finally, AWS uses these access levels for IAM permissions, like list, read, write, permissions management.
Okay.
Understanding those can help you figure out what level of access you're actually giving.
All right. So IAM practices: secure the root user, least privilege, strong passwords, MFA, rotate credentials, monitor and understand access levels. A lot to keep in mind.
It is, but it's all about building a secure foundation.
Now, to really drive home how important that root user is, can you give some examples of tasks that only the root user can do?
Sure. Things like changing the account name or email, managing the root user password and access keys, recovering IAM user permissions, giving access to the billing console, sensitive stuff.
Oh, yeah.
And also closing your AWS account, changing your support plan, registering for certain marketplaces. It's the ultimate power.
So basically, the root user is for those super important account level actions.
Exactly.
Okay, we've covered a lot of ground with IAM. Let's shift gears and talk about VPC, the virtual private cloud. Earlier, you said IAM was like the security guard. Is it fair to say that a VPC is like my own private network within AWS?
Absolutely. A VPC is like your own virtual data center in the cloud. It's isolated from other VPCs. You have full control over your networking environment. IP addresses, subnets, routing, gateways, all within this private space.
So it's like my own little network bubble within AWS.
Exactly. You can connect to other VPCs if you need to, but the basic idea is isolation and control.
I like it. Now, geographically, where does this VPC live?
A VPC is always tied to one specific AWS region.
Okay.
But here's the cool part. It can span all the availability zones within that region.
Oh, that makes sense.
So you can build apps that are highly available and fault tolerant.
By spreading them across multiple AZs.
Exactly. And when you create a new AWS account, you automatically get a default VPC in each region.
Oh, handy.
Right. Within a VPC, you create subnets.
Subnets.
Yeah, they're like smaller networks within your VPC. Each subnet lives in a specific availability zone.
Okay, so VPC in a region, subnets in AZs. What are the main components that make up a VPC?
There's the CIDR block and subnets, the implied router, route tables, the internet gateway, or IGW, the virtual private gateway, or VGW, security groups, and network ACLs.
Okay, wow, that's a lot. Let's break it down.
Sure.
Starting with the CIDR block, what is that?
CIDR stands for Classless Interdomain Routing.
Okay.
It defines the range of private IP addresses that your VPC will use.
Like 192.168 something something.
Exactly. You choose a CIDR block, like 10.0.016, when you create the VPC. And you can't change that main block later.
Oh,
But you can add secondary blocks to expand your address space.
I see.
And then within that CIDR block, you create your subnets.
Right.
Each subnet gets its own range of IPs from the main block.
Okay.
Few rules. Subnets can't span multiple AZs, and their IP ranges can't overlap.
Got it. So CIDR is the big pool. Subnets divide that pool. Now, you mentioned something called an implied router. What's that about?
It's like the traffic cop inside your VPC. It handles the routing of network traffic between subnets and to the outside world.
Okay.
The good news is you don't have to manage it directly. AWS takes care of it.
Oh, that's nice.
It's there, working in the background, and by default, it makes sure all subnets within your VPC can talk to each other.
So no need to set up extra routing rules for that?
Nope, it's automatic.
Okay, next up. Route tables.
Every subnet needs a route table.
Okay.
It's basically a set of rules that tell traffic where to go. Like, if traffic is destined for the internet, send it to the internet gateway.
Oh, I see
You
it.
get a default route table when you create a VPC.
Okay.
But you can create custom ones for specific needs, one subnet, one route table at a time.
Got it.
But a single route table can be associated with multiple subnets.
Okay.
And remember, communication between subnets in the same VPC is always allowed.
So even with custom routing, subnets can still talk to each other within the VPC.
Absolutely.
Now, what about getting traffic in and out of the VPC, to the internet? That's where the internet gateway comes in?
You got it. The Internet Gateway, or IGW, connects your VPC to the public internet.
Okay.
It's a managed service, highly scalable, redundant, available.
All the good stuff.
Yeah, you don't have to worry about managing it. But you can only have one IGW per VPC.
Okay, one internet gateway per VPC. And it handles both IPv4 and IPv6.
It does.
Now, you also mentioned a virtual private gateway, or VGW. Sounds similar but different.
It is. The VGW is for connecting your VPC to your own on-premises networks.
Okay, like my office network.
Exactly.
Yeah.
It's the backbone of hybrid cloud setups.
Okay.
Also managed, scalable, redundant, highly available.
It's familiar.
Yeah, similar to the IGW. And just like the IGW, you can only have one per VPC.
Got it.
One thing to note, there are limits on the number of VPN connections and VGWs you can have. Check the AWS documentation for the latest details.
All right, IGW for internet, VGW for connecting back home. We're almost done with the components. What are security groups and network ACLs in a nutshell?
They're your security guards at the network level. Security groups act as firewalls for individual instances.
Like virtual servers?
Yep. They control incoming and outgoing traffic. And they're stateful. It means if you allow traffic in, the response traffic is automatically allowed out. You don't have to open up both directions manually.
Oh, that's convenient.
It is. Network ACLs, or network access control lists, are firewalls for entire subnets.
Okay.
They're stateless, so you need to explicitly allow traffic in both directions.
So security groups for individual instances, network ACLs for entire subnets.
Got it.
Yeah.
We'll probably dive deeper into those in a future episode.
Looking forward to it. Now let's talk about public and private subnets. That seems like a fundamental concept.
It is. It's all about whether instances in a subnet can be reached directly from the internet. And this ties into public versus private IP addresses.
No.
Public IPs are, well, public. They're routable on the internet. Anyone can connect to them.
Right.
Private IPs are for internal use within your network. They're not directly accessible from the internet.
Okay, so public for internet-facing stuff, private for internal stuff. What makes a subnet public?
Two things. First, it has to be in a VPC that has an internet gateway attached.
Right, that makes sense.
And second, its route table has to have a default route that points to that internet gateway.
Okay.
That route tells traffic going outside the VPC to go through the IGW.
So the traffic knows how to get out to the internet.
Exactly.
And a private subnet just wouldn't have that route.
Right. It wouldn't have a direct route to the internet gateway, but instances in a private subnet might still need to talk to the internet.
Like for updates or something?
Exactly. For that, you can use a NAT gateway.
NAT gateway.
It sits in a public subnet and acts as a middleman. Instances in the private subnet can talk to it, and it can talk to the internet.
Oh, I see. So it's like a controlled gateway to the internet for private instances.
Exactly. Keeps them secure while allowing them to communicate.
Pretty clever.
No.
All right. Public subnets for internet-facing stuff, private nets for back-end stuff. Got it. Now, let's talk about connecting our VPC to our own on-premises network, hybrid cloud stuff.
Right.
What are the main ways to do that?
Two main options, VPN and Direct Connect.
VPN, I know that one. Virtual Private Network.
Yep. It creates an encrypted tunnel over the public internet between your network and your VPC.
All right.
VPNs are relatively easy to set up, and they're cost-effective.
Right.
And even though they use the internet, the encryption makes them secure.
Good to know.
But because it's the internet, the performance can vary.
Right. Sometimes the internet can be a bit unpredictable.
Exactly.
What about Direct Connect?
Direct Connect, or DX, is a dedicated private connection.
Okay.
It doesn't use the internet. You get a physical connection between your network and AWS.
Oh, wow.
Much lower latency, much higher bandwidth.
But probably more expensive, right?
It can be. And it takes longer to set up because it involves physical infrastructure.
Makes sense.
And one thing to remember, it's private, but it's not automatically encrypted.
Oh, okay.
So you'd still need to handle encryption yourself if you need that.
Got it. So VPN for easy and cost-effective. Direct Connect for high performance and privacy.
Pretty much.
Okay, to make all this more concrete, let's look at that Project One example from the material.
Yeah, good idea.
So the requirement was to design a web app hosted in a VPC with a CIDR block of 10.0.0.016.
Right.
And it needed 2 public subnets in different AZs and 2 private subnets in those same AZs.
Okay.
So how does this design work?
It's all about separation and availability.
Yeah.
The web servers, the public-facing parts of the app, go in the public subnets.
Right.
Those subnets have a route to the internet gateway so traffic can get in.
Okay.
The back-end stuff, like databases, goes in the private subnets.
Okay.
No direct route to the internet, more secure. And by using 2 AZs, if one goes down, the app can keep running in the other one.
Ah, that's clever. So it's secure and resilient.
Exactly.
All right, a great example of putting all these concepts together. Well, we've covered a ton of ground today. AWS Global Infrastructure, the AWS website, IAM, and VPC. Those are the building blocks, right?
They are the foundation of AWS.
And hopefully you, dear listener, now have a solid grasp of those core concepts. We tried to keep it clear and concise. No fire hose of jargon.
Yeah, just the essentials.
Right.
It's amazing, though, when you think about the global scale of AWS and the fine-grained control you get with IAM. It makes you wonder how organizations can use these tools not just for deploying apps, but for managing complex data regulations and security challenges.
Yeah, it's a lot of power in the hands of the user.
Definitely.
And if you want to keep learning, I'd suggest checking out the AWS Management Console.
Yeah, get hands-on.
Or dive deeper into specific services like EC2, the virtual servers, or S3, the storage service. There's so much to explore. Thanks for joining us on this deep dive.
Thanks for listening.